A craftswoman wants to make a rectangular tabletop, but the only wood she has available has already been cut into a parallelogram as shown in the figure below. What is the area of the largest rectangular tabletop she can cut out of this parallelogram, assuming that it must be a single piece of wood? So single piece of wood, and we're looking for the area. We're looking for the area of the largest rectangular tabletop that can be cut out of this parallelogram. Okay, let's go ahead and get started. So before we do that, we know that in order to make this a rectangle, we're going to have to cut right over here. And because we know that it needs to be a rectangular tabletop, it needs to have a 90-degree angle, and that's where that 90-degree angle forms. So we have almost all the information we need in a case like this. So we know that the area, I'll write that here, we know that the area of our tabletop is going to be equal to length times width. I'll just call that length times width, and I'll call this measurement right over here length, or actually I'll call this measurement right over here length, and I'll call this measurement right here width, and that's from here to here. That's our width. And in order to figure this out, we just have to do a little bit of math here. And if we know what this side right here is, we can actually subtract that off from this entire side length of 10, because we know that this side right here, we can just go ahead and call this, let's call this side length B. And that means this is also going to be B by the definition of rectangles and parallelograms. So we know that we can set up a Pythagorean identity right over here. So we know that B squared plus 6 squared is going to be equal to 8 squared. And so we can solve this very simply by saying b squared plus 36 is equal to 64. We subtract 36 from both sides, and we get b squared is equal to 28. And therefore, b is equal to square root of 28. So that's our value right here. b equals square root of 28. That's this measurement right over here. Right over there. Okay, wonderful. So we have almost all the information we need. Let's set up our rectangular tabletop. The length of this rectangular tabletop is going to be equal to this L right here, which is the same as this height right over here. So this is going to be 6 feet. And we know this measurement right over here, this width over here for the rectangle, is going to be this 10, this value of 10. 10 is all the way from here to here. That's 10 feet right there. And we know it's going to be 10 minus b, right? This length over here is going to be 10 minus b, and we know b is equal to the square root of 28, so this is going to be 10 minus square root of 28. And now all we need to do is plug in all our length and width into our area formula. So let's go ahead and do that here. We know that the area of the tabletop is going to be equal to length times width, which is going to be equal to 6 times our quantity 10 minus root 28. And we can do this by distribution. So 6 times 10 is equal to 60 minus 6 square root of 28. Does our answer look like any one of these? Do any of our choices look like the answer that we just got? It does not, so we're going to have to simplify a little bit. And I'm going to do that by simplifying this radical over here. So that's going to be equal to 60 minus 6. And here's what I'm going to do. I'm going to do this as square root of 7 times 4. And what I can do is I can take the square root of 4 and move it to the outside of this radical. So that's going to be equal to 60 minus 6 times 2 square root of 7. Because that 4, the square root of 4 is equal to 2, and I can take that out and multiply it by the 6 here. And that gives me 60 minus 12 square root of 7. And keep in mind that our answer is going to be in feet squared. So our answer is 60 minus 12 root 7 square feet. And that does look exactly like one of our answer choices, and that is going to be D for donut.